fire pumps and generators often go hand in hand. The National Electrical Code, specifically Section 701.10 of the 2020 edition, addresses this relationship by requiring a standby generator for fire pump loads, except where specifically exempted. The rationale behind this requirement is that fire pumps are considered life safety equipment. They are essential for fighting fires and protecting life and property. In the event of a power outage, a standby generator is necessary to ensure that the fire pump can continue to operate. There are a few exceptions to the requirement for a standby generator for fire pump loads. Firstly, fire pumps that are powered by an uninterruptible power supply or UPS may be exempt. Secondly, fire pumps that are part of a dedicated standby power system may not require a separate generator. Thirdly, fire pumps that are used in certain agricultural applications may also be exempt from the generator requirement. Let's delve deeper into the specific requirements outlined in NEC 701.10. This section mandates an alternate source of power for systems legally required to have standby power. The standby system must automatically supply power to the designated equipment within a specified time after a power outage. This ensures a seamless transition and continued operation of critical systems, including fire pumps. Examining the exceptions more closely, the use of a UPS as an alternative power source relies on stored energy, typically batteries, to provide power during an outage. The UPS must be capable of supplying power to the fire pump for a sufficient duration to meet the fire suppression needs of the facility. The suitability of a UPS depends on factors such as the size of the fire pump motor, the battery capacity, and the anticipated duration of power outages. A dedicated standby power system refers to a power system that is specifically designed and installed to provide backup power to a limited set of essential loads, including the fire pump. This system may consist of a generator, transfer switch, and associated wiring and protection devices. The advantage of a dedicated system is that it is specifically tailored to the needs of the fire pump and other critical loads, ensuring reliable and adequate power during an outage. Considering agricultural applications, the exemption for fire pumps in these settings recognizes that the fire risks and power reliability considerations may differ from those in commercial or industrial buildings. The specific conditions under which an agricultural fire pump may be exempt from the generator requirement would be determined by the local authorities having jurisdiction, or ODJ, based on factors such as the size and type of agricultural operation, the availability of alternative water sources, and the potential impact of a power outage on fire suppression capabilities. In conclusion, the NEC 701.10 requirement underscores the importance of backup power for fire pumps. While exceptions exist, the general rule is that a standby generator is required to provide backup power for fire pumps in the event of a power outage. Understanding the code requirements and the available alternatives is crucial for ensuring the reliable operation of fire pumps and the safety of life and property. It is always recommended to consult with a qualified electrical engineer or contractor to determine the specific requirements for a particular installation and to ensure compliance with all applicable codes and standards. The code is very specific about what is required for fire pumps and generators, including the specific wiring methods and overcurrent protection to ensure that the fire pump will operate when needed, even under abnormal conditions. The intent is to ensure the fire pump has the highest reliability possible. In summary, fire pumps and generators are intrinsically linked due to life safety considerations and code mandates. While exceptions exist, a standby generator is generally required to provide backup power to fire pumps, ensuring their reliable operation during power outages and safeguarding life and property. It's very important to refer to local authorities having jurisdiction, known as AHJ, because they have the final say on the interpretation and application of codes and standards in a specific region. The AHJ can provide guidance on specific requirements and exemptions related to fire pumps and generators in the area. The size of the generator needs to be carefully considered, not just for the fire pump but also for any other loads that are required to be on the emergency system. This calculation needs to consider the inrush current of the fire pump motor and other loads, as well as the continuous load requirements. The transfer switch is another critical component in a fire pump and generator system. The transfer switch automatically switches the fire pump from the normal power source to the generator when a power outage occurs. The transfer switch needs to be listed for fire pump service and be able to handle the high inertia current of the fire pump motor. Proper maintenance is essential for both the fire pump and the generator. Regular inspections, testing, and maintenance can help to ensure that the equipment is in good working order and ready to operate when needed. The generator should be tested regularly under load to verify its performance. Some jurisdictions may require the fire pump and generator to be tested annually or more frequently. The test procedure should follow the recommendations of the manufacturer and applicable codes and standards. Fire pump installations are often subject to specific inspection and approval requirements. These inspections are typically conducted by the local fire marshal or other authorized representative. The inspection will verify that the fire pump and generator system is installed and operating in accordance with the applicable codes and standards. Proper documentation is essential for fire pump and generator systems. This documentation should include the design drawings, equipment specifications, test reports, and maintenance records. This documentation can be used to verify compliance with the applicable codes and standards and to provide a record of the system's performance over time. The National Fire Protection Association, known as NFPA, standards also provide guidance on the installation and maintenance of fire pumps and generators. NFPA 20 covers the installation of stationary fire pumps for fire protection, and NFPA 110 covers emergency and standby power systems. These standards provide detailed requirements for the design, installation, testing, and maintenance of fire pumps and generators. It is very important to stay up to date with the latest codes and standards. The codes and standards are constantly evolving to reflect new technologies and best practices. Staying up to date can help ensure that fire pump and generator systems are installed and maintained in accordance with the latest requirements. When it comes to the wiring for fire pumps and generators, there are specific requirements that must be followed. These requirements are designed to ensure that the wiring is able to withstand the harsh conditions that may be present during a fire and that the fire pump will continue to operate even if the normal power source is lost. The wiring must be protected from physical damage. This can be achieved by using conduit or other suitable means of protection. The wiring must be rated for the voltage and current of the fire pump motor and generator. The wiring must be sized properly to prevent voltage drop. The wiring must be installed in accordance with the National Electrical Code (NEC). The overcurrent protection for fire pumps and generators must also be carefully selected and installed. The overcurrent protection is designed to protect the wiring and equipment from damage in the event of a fault. The overcurrent protection must be sized properly to prevent nuisance tripping. The overcurrent protection must be coordinated with the other protective devices in the system. The overcurrent protection must be installed in accordance with the National Electrical Code (NEC). The grounding of fire pumps and generators is another important consideration. Proper grounding helps to protect people from electric shock and to prevent equipment damage. The grounding system must be installed in accordance with the National Electrical Code (NEC). The grounding system must be properly maintained to ensure its effectiveness. The specific requirements for grounding fire pumps and generators can be found in the NEC. Regular testing and maintenance of fire pumps and generators are essential to ensure that they will operate reliably when needed. The testing and maintenance should be performed by qualified personnel in accordance with the manufacturer's recommendations and applicable codes and standards. The testing should include a visual inspection of the equipment, a functional test of the fire pump and generator, and a load test of the generator. The maintenance should include cleaning the equipment, lubricating moving parts, and replacing worn or damaged parts. Proper training is essential for anyone who will be operating or maintaining fire pumps and generators. The training should cover the operation of the equipment, the maintenance procedures, and the safety precautions that must be followed. The training should be provided by qualified personnel and should be documented. In summary, fire pumps and generators are critical components of a fire protection system. Proper installation, maintenance, and testing are essential to ensure that they will operate reliably when needed. Following the applicable codes and standards and providing proper training to personnel are also important for ensuring the safety of people and property. The specific requirements for fire pumps and generators can vary depending on the location and the type of facility. It is important to consult with a qualified electrical engineer or contractor to determine the specific requirements for a particular installation. There may be specific local amendments or regulations that apply in a particular jurisdiction. Understanding these local requirements is essential for ensuring compliance and the safe and reliable operation of the fire pump and generator system. When designing a fire pump and generator system, it is important to consider the future needs of the facility. The system should be designed to accommodate future expansion or changes in the facility's fire protection requirements. The system should also be designed to be easily maintained and upgraded. When selecting equipment for a fire pump and generator system, it is important to choose high-quality equipment from reputable manufacturers. The equipment should be designed for the specific application and should be able to withstand the harsh conditions that may be present during a fire. The equipment should also be backed by a good warranty and service support. When installing a fire pump and generator system, it is important to follow the manufacturer's instructions and applicable codes and standards. The installation should be performed by qualified personnel with experience in fire pump and generator systems. The installation should be inspected and tested to ensure that it is working properly. One should consider the environmental impact of fire pumps and generators. Generators can produce emissions that can contribute to air pollution. It is important to select generators that are designed to minimize emissions and to operate them in accordance with environmental regulations. Fire pumps can consume significant amounts of water. It is important to design fire pump systems that are water efficient and to consider the availability of water resources. Some buildings may have a combined fire protection system, which uses a single fire pump to supply water to both the sprinkler system and the fire hydrants. In these systems, it is important to ensure that the fire pump is sized properly to meet the demands of both systems. In buildings with multiple fire zones, it may be necessary to provide multiple fire pumps or to use a zone fire pump system. Zone fire pump systems allow for the fire pump to be activated only in the zone where the fire is located, which can help to conserve water and energy. Fire pump systems should be designed to be accessible for maintenance and repair. The equipment should be located in a well-lit and ventilated area with adequate space for personnel to work. The equipment should be easily accessible for inspection and testing. Fire pump systems should be protected from unauthorized access. The equipment should be located in a secure area and should be equipped with locks or other security devices. Unauthorized access to fire pump systems can compromise their reliability and effectiveness. It's important to conduct a hazard analysis of the fire pump system. A hazard analysis can help to identify potential hazards associated with the fire pump system and to develop measures to mitigate those hazards. The hazard analysis should consider the potential for fires, explosions, electrical shock, and other hazards. It is very crucial to have an emergency response plan for the fire pump system. The emergency response plan should outline the procedures to be followed in the event of a fire or other emergency. The emergency response plan should be communicated to all personnel who are responsible for operating or maintaining the fire pump system. Fire pumps and generators are complex systems that require careful planning, design, installation, and maintenance. By following the recommendations outlined in this narration and consulting with qualified professionals, it is possible to ensure that fire pump systems will operate reliably and effectively when needed to protect life and property. Always remember the importance of documentation. Complete and accurate documentation is essential for fire pump systems. This documentation should include the design drawings, equipment specifications, test reports, maintenance records, and emergency response plan. The documentation should be stored in a safe and accessible location. Review the fire pump system periodically. The fire pump system should be reviewed periodically to ensure that it is still meeting the needs of the facility. The review should consider changes in the facility's occupancy, layout, or fire protection requirements. The review should also consider any new codes or standards that may apply. Consider the use of remote monitoring for the fire pump system. Remote monitoring systems can provide real-time information on the status of the fire pump and generator. This information can be used to identify potential problems early and to take corrective action before a fire occurs. Look into using energy-efficient fire pump systems. Energy-efficient fire pump systems can help to reduce the operating costs of the facility. These systems use variable speed drives and other technologies to optimize the performance of the fire pump. The reliability of the fire pump system can be enhanced. This can be achieved by using redundant components and by providing backup power to the fire pump. Redundant components can ensure that the fire pump will continue to operate even if one component fails. Backup power can ensure that the fire pump will continue to operate even if the normal power source is lost.